Hello, good morning.
Good
Hello,
morning, sir.
good morning. Good
Good
morning.
morning, sir.
Good morning. So, last time we have seen the different mixers. Is maybe the high speed mixers, maybe paddle type mixers, or maybe plenty type of mixers, the sigma type of mixers, right? These are the mixers which are used for solid as well as a semi-solid formulation and to prepare that different formulations, right? So today we'll see next mixer. It is called as a ribbon type of the mixer. So is the name itself is a like same as to like the ribbon, right? So if you have seen that the structure of that ribbon, so this is the horizontal axis. So this horizontal axis we can rotate that mixer, right, with the different rotations with a different speed, right? Then these are the different two shafts are there, right? So these are red color is one shaft and other is the yellow blue color is other shaft, right? So these shafts uh, which are rotated with the own axis, right, with simultaneously, right? So these processes which are doing simultaneously only, right? So this above the figure, if you have seen that, so you attach with the motor. So this motor is attached to that, right? And this is shaft. In shaft in between, all right, in that shaft will be attached with the uh, two ribbons, right? One ribbon is the left side, it's at the left side, and the another ribbon is the right side, right? And you can rotate it to this one axis is simultaneously. So the possible is a to mixing of that semi-solid formulation is 100%. All right. So if you see the construction of the ribbon mixer is consist of the horizontal cylindrical trough, right? With a semi-circular bottom usually open at the bottom, right? Suppose if you have seen that these both these ends are there, it is the input and this is output, right? So material which are put up into this by this vent, right? It is a first vent and second vent and the third vent. So above the two vents which are required for to inserting of the to put up that material into that the mixer, right? Then after this mixing, right, then you can collect that material, material from the discharge vent. So this is again that the below side is a discharge vent. Understand it? So is every time, so this above the red color which are rotated is the different rotations, and is a blue color which are rotated is a different rotations, right? So in that case, so every particle will be mixing, right, can passing from the one place to other places, and to 100% mixing is possible with this the ribbon type of the mixer. The same as to ribbon like, and if you know that तुम्ही just ribbon घेतला आणि just तुम्ही vibrate केलं ribbon, right? Whatever this vibrations is the same vibrations is that for the ribbon also, right? Then it is a fitted to the two helical blades are there. So these are the blades are there, the first blade and the second blade, right? So which are mounted on the same shaft through the long axis of the trough. So blades are at both the right and left hand twist. These are the different twists are there, right? So if you have just vibrate that the ribbon, right? So different twists will be possible. Understand it? And this is that's why it is called as a ribbon-like structure of that ribbon mixer. So blades are connected with the fix the speed of the drive, or we can use the motor as a with the motor we can rotate that shaft, and with the rotation of the shaft again that blades can be rotated again, and is very negligible. There is a gap in between the wall and the blades are is a larger size, or it is a, if you see the back gap is very minimum, right? So this is a red color and is a blue color again. So gap is very minimum. So every material which are passing through that gap, so can reduce its particle size, and to 100% uniform mixing is possible. So it can be loaded by the top, by the and emptied done is by the from the bottom, right? So you can just loaded that from the top and unloaded from the bottom side. Then this principle of that ribbon mixer is a mechanism of the mixer is sharing. To apply the sharing with this two ribbon or the two shafts, the two blades are there. Shearing is transferred by the moving the blades. So the various speed of the blade we can moving at that own axis and to is create the shear, create the force, and with that force, like breaking the lumps and aggregates. Right. So it's particularly this used for where is a semi-solid mixing, or we can, if you want to prepare the granulation, if you want to prepare that the ointments, right? So the larger lumps we can break down, and which are from the smaller lumps, or we can reducing particle size by applying the shearing force. That's not it. So how the shearing force is created due to this? The speed of give the speed of that shaft or the blades, and which are create the force. The highest shear rate will be affecting to effective breaking the lumps and aggregate. It's also this converting mixing is there, right? So because in converting mixing, so after this rotation of that ribbon, right? So this particular material which are going in the particular materials which are going at the upward side, and again we can fall into the downward side. So every time is possible, right? We can going upward side, again I can fall at bottom side, right? And every material we can be mixing, and that process it is called as a cascade type of the mixing, right? Which are going upwards and downwards, going upwards and downwards. It is many times it will be happen, and that process is called as a cascade mixing. So equilibrium is so equilibrium state of the mixing is achieved. So it's a particular timing, the particular speed of the rotation, right? And with that, if you apply the particular timing and the speed of rotation, right? So some of this equilibrium state will be achieved, and to stop your that mixing. The uses of that ribbon type mixer is mixing of the finely divided solids, the weight solids or plastic solid also. Uniform size and the density material can be easily mixed. So those how the materials are non-uniform size or maybe differences in the densities, right? So we can difficult to mixing with this ribbon mixer. But those have the uniform size particle size, those are the uniform density, right? Then it is be easily mixed with this material, which are used for the solid-solid mixing as well as the liquid-solid mixing. That is a semi-solid as well as the liquid. Solids. Then our advantages of that ribbon mixer is the high shear can be applied using the perforated baffles can be used. Again, this if you see the figure, right? So this figure, then some of this the baffles may be small the knife we call it as a small knife. So small knife which are also you can attach to that the side of that wall, right? So you can attach with that in this is the first step. Sorry. The first, then this is also the second and the third part. So wherever the gap is there, you can just attach the different baffles. So baffles is a small size of the knife is there. You can do after this is give if you have given the speed of the speed of that knife, right? Again we can reduce its particle size, and the 100% mixing is also possible, right? So that's why this the advantages we can use the different baffles, perforated baffles we can use. So can cut down that different particles. So the particles can reduce its larger size to the smaller size with the rubbing and the breakdown of the aggregates. You can rub, right? You can rubbing that particles, so can reduce its particle size from larger to lower, larger to small size, right? And you can break down the aggregates and reduce its particle size. Then the disadvantage of that the ribbon mixer is which are poor mixer because the movement of the particle is two-dimensional mixers are there. So if there is the particles are non-uniform size, if the particles are density is not uniform, right? So the mixing is possible, that is poor mixing, right? Then shearing action is very less than the planetary mixer because there is two blades are used, and the two blades the shearing force is very less. And with the shearing force, right, so those have the sticky material, those have the highest semi-solid formulation, it cannot be used for that this type of the ribbon mixer. But that can be used in a planetary mixer can be used, we have seen last time. Then the dead spots are absorbed in the mixer through that minimum. All right. So dead spots also can absorb at that bottom of the at the side of that mixer. So it's maybe at that side is maybe dead spot is there. Maybe at that side dead spots is there. So dead spots means that so where mixing is not possible. So these metals are at the corner of the metal will not be participation in the mixing. So that process it is called as a dead spots process, right? Then dead spots are observed in the mixer through that very minimum. You can fix speed drive. The drive space is not suitable for those are the fragile crystals or the sensitive material. Due to this rotation of that speed, rotation of the ribbon, it may create the temperature, and with the temperature, it may chances there is a melting of the some of the substances, and it's create the problem. So those have the hygroscopic material, those have the low melting point material, so it cannot be used for ribbon type of mixers, right? And those are the fragile crystals. The fragile crystals means those are the very softened crystals are there, right? So with this pressure, with the shearing force, we can reduce its particle size and gets fine powder. So very fine powder may be possible, right? So very fine powder is may be possible because the particles are very soft in nature or fragile in nature. Okay. Then the next we'll see next mixer is that is a homogenization. So we know that in our laboratories, in particularly in the pharmaceutics or the QA laboratories, we have the different types of the homogenization. Homonizer is there. So homogenization is a process, right? Understand it. So homogenization is process, and for this homogenization, we can use different types of the equipments and the instrument that is called as a homogenizer, right? So homogenization is process for converting the non-uniform mixing to the uniform mixing. But जे काही uniform mixing है, it can convert into the uniform mixing, and that is will be possible with the homogenization. So you can use a different types of homogenizer for this homogenization. So it is done for the reducing the particle size and the uniform distribution is possible, right? So to make the product is the uniform products. So make the product is homogeneous products. Means every particles are mixing very 100% and to form a homogeneous mixture with this the homogenization, right? So the example of this converting the coarse emulsion to the colloidal emulsion. So for the preparation of that emulsion, right, as you know this, the emulsion is containing the two phases are there, oil and water, and this oil cannot be mixed in the water. So it's required the highest shearing force, right? So can reduce particle size of the oil globules, or the largest type of the oil globules are there, which are reduces the size of the globules from the largest to the small size, and after the small size of the globules, you can prepare the emulsion, right? You can convert the coarse emulsion or the coarse particle coarse globule size into the fine globule size, right? And it will be possible to prepare the emulsion. So for the homogenization or the homogenizer, you can use for the preparation of the colloidal type of the emulsion you prepared it. So homogenizers can be used to prepare biophysics systems are there. So this may be suspension or maybe emulsion. So as you know this, the suspension, those are the finely divided solids, is not be dissolved in the liquid, but it remains suspended in the liquid, right? So that's why the solid particles should be uniformly distributed into that liquid is essential for stabilization of the suspension because it's biophysics. And same is for the emulsion also. So can reduce its particle size. So if the particle size of that solids is very high in a suspension, so that suspension is not be stable. So can reduce its particle size from the largest particle size to the smallest particle size with the help of the homogenization, right? And after this, the very fine particle size, and that particles are which are uniformly distributed into the liquid and stable the suspension is possible. And same is for emulsion also. Then, so for the homogenizers, we can use different types of the modified turbines are used, right? It is called as a modified turbines. So it consists of the turbine and stator. These are the two parts of that homogenizers you can use, turbine and stator, right? So this turbine and stator is a certain distance in the mixer, we can fix it. So rotation of the turbine at the various speed, which will create the pressure differences, and due to that pressure, it reduces particle size. Right? So it is rotation. The different turbines and stator we can attach to the homogenizer, and with that turbine and stator, if you have rotate that turbine at the various high speed, you can create the pressure, right? And after creating the pressure, you reduces particle size, global size, right? And you can prepare the suspension as well as the emulsions. Those are the biphasic doses from that there. Then next process is that, so if you want to reduce particle size, then through this stator and turbine. So particles and the fluid which are passed through the stator and turbine. So means that is the emulsion. If you want to prepare the very stable emulsion, the emulsion having the finely globules are there. Then there is a coarse emulsion we can passing to that the zone, and the zone is having the highest speed of the stator and turbine. And due to that, the speed of the stator and turbine can reduces the global size, right, with the pressure. You can create the pressure. With that pressure, we can reduce its particle size, reduces the global size, and after reducing the global size, can prepare the emulsion. So this is which producing the mechanical force to obtain uniform or homogenized mixture. So homogenized mixture is formed with the help of the homogenizer to prepare the mixers to prepare that different emulsions or the suspension that is possible with the homogenizer. Then we can use a different types of the homogenizers. We can use first is called as a pressure homogenizers. All right. So pressure homogenizers, with that pressure homogenizers, we can create the highest pressure pump. All right. So the pressure pump which are fitted in the mixer. Understand it? So fitted in the mixers, with that the pump can create the highest pressure. Understand it? It can create the highest pressure. With that pressure, reduces the particle size from the larger size to smaller size, and finally divided dispersion is possible. Right. So can create the pressure, right? So can attach with the we can just install that different there's a pressure pump, and with that pressure pump we can create the highest pressure, and with that pressure we can create that pressure. With that pressure can reduces particle size, can reduces the very larger global size to the reducing that is a small global size, right? This is called as a pressure. So we can apply the pressure with the help of the pressure pump. Then electronic homogenizer also is one of this ultrasonic homogenizer, right? With this ultrasonic homogenizers, we can use the ultrasonic waves, right? So we have in a pharmaceutical laboratory, so there's a ultrasonicator. If you know that instrument, the ultrasonicator. The ultrasonicator is it is used for enhancing the solubility of that bath. It is called as bath ultrasonication bath. So it's mainly content of the ultrasonic waves are there, right? It's the frequency of the waves is 20,000 hertz, and with that waves can generate the vibrations. Ultrasonic waves, you can generate vibrations. With that vibrations, right, you can uniform dispersion of the mixture is possible. With the ultrasonic waves, we can producing which are create the shear, and with that shearing can reduce the particle size, and homogenization is possible. It's primarily this ultrasonic homogenizers we can use to prepare the emulsion or emulsification. Then homogenization is a process to preparing fine emulsion from the coarse emulsion. So what is meant by coarse emulsion? Coarse emulsion is this type of the emulsion is not be stable for longer time. Understand it? So this coarse emulsion is having the global size is larger, so that's why it's not stable. So this the coarse emulsion we can convert into the fine emulsion. That process is called as the homogenization. Can converting from larger globule size to the smaller globule size. That is process is called as homogenization. And what is the homogenization is done? The apparatus is used as a homogenizer. So the principle of that homogenization is based on the principle that is a larger global size in a coarse emulsion is broken into the smaller global size passing under the pressure through the narrow orifice. Narrow orifice there. So we'll see in a direct instrument what is narrow orifice. Right. So this is a coarse emulsion which are passing to that with a narrow size of the orifice with the pressure, right? And after passing to the narrow size of the orifice, can reduces the globule size from larger globules to the smaller globules. Understand it? So commonly used homogenizer is hand homogenizers or Silverson mixer homogenizers or colloidal emulsifiers is also there. So the hand homogenizers, so the first is hand homogenizers. So it's not be operated by the machine or the motor. You can just operate it by the hand. All right. So it's based on the principle is larger globules or the in a coarse emulsion which are broken into small globules we can passing under the pressure to the orifice. Right. Then it consists of the hopper and the small orifice and handle and the heavy base. We'll see in the figure. The hand homogenizers consist of the small stainless steel vessel. It's mounted on the stand. So bottom of the vessel is opening at the feet nozzle. The freely moving the piston is operating into the cylinder. All right. So we'll see the figure. Then we have better understand. Right. So these are hand homogenizers there. So this is called as a hopper. So first is a hopper. Just can putting that the coarse type of the emulsion. Just you can prepare the emulsion with the help of mortar and pestle, right? And then this emulsion which are put up into that the hopper, right? Then this handle is there, so can operate the handle, right? And this last part is called as base. The heavy base is there, so during the handling of this is a handle, so can operate from up and down motion, right? So with that up and down motion, we can create the pressure, all right? And after creating the pressure, so whatever the metal in the hopper which are coming down at that into the hole. This is one of the spindle is there or is called as a narrow orifice size. जिथं orifice size इथं कमी आहे, orifice size बरोबर, जे orifice size इथं जास्त आहे, हे total hopperची orifice जास्त आहे आणि हे same emulsion हे पास होते इथून आणि इथं आहे ते स्मॉल ऑरिफिस साइज नोझल आहे, राईट. ते स्मॉल ऑरिफिस साइज नोझल आहे आणि हे जे कोर्स इमल्शन याच्या पासिंग याच्यामधून पास झाल्यानंतर काय होईल, जे ग्लोबल साइज जे जास्त मोठे आहेत, राईट. सो कॅन reduce that the global size from the larger global size to can reduce the fine global size with the help of the hand operated homogenizer is also there. So the emulsion is you can passing through that the small orifice into that the orifice through the homogenizers, and through that orifice can reduce the global size from the larger global size to the fine global size is possible. And so this just you can this handle can operate at up and down motion, so you can create the pressure, and with that create the pressure, right. So this metal is are passing from the hopper to that the fine orifice, and you can collect the material from this is a stage to collect the material. So you can put up in a container, put up that container at that side, or maybe beaker at that side, so get the fine emulsion, right. Then this working of the emulsion is in a mortar and pestle. You can just prepare the emulsion in a mortar and pestle. This is a coarse type emulsion. Then the same emulsion which are put up into that the hopper. Then piston is operated. This is a piston or the hand operated piston, and this piston which are create the pressure. So we have seen this piston. So this is a handle is also called as piston, right. Then this the liquid which are homogenized and the pass through the nozzle under the pressure. So you can create the pressure, and after creating pressure, the emulsion is coarse emulsion is passing through that the nozzle, which causes the atomization. So atomization means you can reduce the global size from the larger to the smaller size, and the homogenization is possible. So these are hand operated homogenizer is also there. The second homogenizer is called as a Silverson homogenizer is also there. So what is meant by Silverson homogenizers? So is the name itself. So name is given to that homogenizer. It is called as Silverson homogenizer. So it works on the principle of the combination of the mixing and homogenizer. These are the two principles are there: mixing and homogenization. So construction of that the Silverson homogenization is a consist of the emulsifying head, right, to which the number of the beds are attached. Then it is surrounded by the fine mesh sieves is a made of the stainless steel. The head is rotated by the means of the small motor which rotate the blade and the various speed. Right. So we'll see the figure directly, then we understand. Right. So these are Silverson type of the homogenizer is also there. So this is a stand. The basic stand is there. We can attach that the homogenizers.
Excuse me, sir.
Bolo.
Sir, can you take the previous slide, Silverson?
So you say it's the same as Silverson.
Sir, previous slide.
This one.
Prince.
This one.
Yes, sir. Just a minute.
So we'll go afterwards, right? Just we understand that figure, then we go before, right? Just to understand figure. So this is a Silverson homogenizers can attach with the strong base. This is a strong base is there. During that the speed of that homogenizers may be chances of vibrations. So to avoid the vibration to that that Silverson, right? That's why the base is should be strong, right? Then will be attached that the homogenizer. This is motor. Understand it? So this is a motor. Then this is a shaft which are attached to that the shaft, and this is a particularly this is a stator. We have seen that paddle and stator, right? So this is paddle and stator. So and this is a different type of the stators we can attach with that. So different size and shapes of the stators are there. So you can create the pressure with the help of this the stator, right? Then after this, before you using that the Silverson, just we can clean all this Silverson with the we can remove that or disassemble that the total equipments and clean properly. And after cleaning, then you can dry it properly, then can use for that Silverson. All right. Then take your emulsion and emulsion which are put up under this the Silverson. Okay. So this is the base. So under this Silverson, we can just put up the that is a beaker. So beaker is containing the coarse emulsion. Okay. Then you can start your motor, and this motor after starting the motor, so this the shaft you can rotate it at the various speed. Right. The shaft is rotated at the various speed, and after rotation is create the pressure, is create the shear, and after creating the shear, so what are the larger globes which are converted into the smaller globes, right? Understand it? Then we'll see this Silverson is consist of the emulsified head. So below that it is called as head, right? This is called as head. Understand it? So this head is called as emulsified head. With that is create the pressure, and with that pressure reduces particle size. All right. So then is the number of the blades are attached. So different types of blades which are attached into that. Then surrounded by the fine mesh should be attached with that. Then these are the fine mesh is there. So these are fine mesh. Fine mesh means that if there is the material cannot be going upward side. So this mesh is there. Mesh means the different sieves or the different mesh are there. So what are the emulsion which are not be coming at the upward side. Understand it? So that's why this mesh must be important. Then the head is rotated by the means of the smaller motor and rotated the blades at the high speed. So that we have seen. Then emulsified head is immersed in the liquid. So what is the head is there? We have seen the head. So head just can immerse in the liquid, right, to be emulsified. Right. Then a liquid should be mixed, sucked through the fine mesh, and oil is reduced with the fine globus in this process. Right. So next process that in that if you have seen the figure, right, then this is a mesh is there with a very fine mesh is there, and during the after creating the pressure, what will happen? So what the emulsion in the beaker which are sucked in a various pressure, and after sucking that the various pressure through this small orifice, right, understand it, small orifice, and this then this emulsion is coming at the side, understand it, and with that emulsion, so the coarse emulsion which are passing through that the different orifice can reduces the larger globose size to the smaller globose size, and the fine emulsion is possible, right? So liquids which are mixed to the suck to the fine mesh, and oil can be reduced into the fine globose, right? This is a process of emulsion. So process of emulsion we occur the highest speed of rotation of the blade. The blade is required. So mixed material will pull out, and the great force, and the process of homogenization will occur. That is a simultaneous process. That is a mixing and the homogenization is simultaneous process there. So mixing is possible for the mixing or the homogenization is the possible for it with the blades. The blades are different blades are used. The application of that the mixer is to obtain the fine emulsion or to obtain the suspension. Those are the biophysical liquid doses forms are there. Maybe suspensions are emulsions are there. They can be prepared with this, right? Then this is the same as there. This old figure is there, same as to this motor. Then this is a shaft. This stand is used. Then this emulsified head is there with the fine mesh will be attached. Right. The same is to that we have seen. And the same, this is another silver sun. The electronic motor, shaft, stand, and the emulsified head. Right. So we have seen that. And this is a small size. Right. It's a larger size. This is a small size. So which having the smaller, if the preparation has the very small amount, maybe 10 ml or 20 ml, so that type of the homogenizers can be used. If the quantity is more than maybe 1 kg or 220 kg, maybe 2 kg also there, that can be used at the silver sun. So depending upon the emulsion quantity, we can use the different size of the silver sun emulsion. Right. Then next is mixing equipments. Right. So for that, we can use two different type of the mixing equipments. Right. The batch mixing and the continuous mixing. So batch mixing means that, so if the mixing is a specific and the limited quantity of the material. So if the material is very low, the material is very small amount, or very little quantity is there, right? So you can use that the batch mixing. So batch mixing means the you can prepare the that suspension, the emulsion with a batch wise, right? Batch wise, maybe maybe there is a 1 kg batch or the 2 kg batch is called as batch. But it's continuous mixing is maybe batch size maybe hundreds of kg. So this process is continuous in nature, right? So equipment is the continuous mixing. So equipment is used for the both are different, right? Equipments used for both are different because continuous mixing, the batch mixing, these components may be different. Or the two components are common. So there's a batch mixing and the continuous mixing. The components are the same, but only the size of the mixer, smaller size as well as the larger size. For the larger size, the mixing, right? We can use a larger quantity. The smaller size of the mixer, we can use that as the smallest quantity, right? So, but all the systems are same. So the same systems are there. There's a tank of the suitable size. So you can use the different tanks. Then you can supply the energies to the system to rotate the shaft, rotate that paddle, and we can create the force. We can create the pressure, and we can create pressure, and then can reduce the smaller globules, larger globule size to the smaller globule size with the help of the speed of the mixing, right? Then this is a mixing vessels is there. So it's a general things are there. It's a mixing vessel. All these mixers is mainly for homogenizers. So these are the different components are there. This motor is there, right? Then feed of the material. So these are lead. So this container is attached with the lead. Lead should be closed at the container, right? Then there's a feed. So material we can feed with this, the vent. This motor is attached with the shaft. So the shaft having the different size and shapes of the shaft is there, or maybe paddles, or maybe stator are there, right? With the stator we can create the pressure, or it is also called as a agitator, right? So this agitator can agitate the that liquid, and then this is a feeding mechanism. Feeding material can feed into that, and this is again the blue color is called as a baffle, right? So baffle, because the baffle is required for to 100% mixing is possible, because if you are mixing in this side, so suppose हे बघितलं तुम्ही हे कंटेनर हे आणि हे स्टार्टर आहे किंवा पॅडल आहे, हे मूव्ह होत असताना हे वेगळ्या स्लाइडने मूव्ह होईल, right? So material is going upward side and then again the downward side. Understand it? So both this process will be happen, but काय होईल की समजा की फक्त जे एरिया आहे तो फार कमी आहे, फक्त सेंट्रल एरिया आहे, त्या साईडला दोन्ही साईडला कंटेनर मध्ये तुम्ही बॅफल तुम्ही यूज करू शकता, लेफ्ट साइड आणि राइट साइडला पण. सो बॅफल इज अ स्मॉल साइज ऑफ द नाइफ we call as, right? With the given the high speed of that baffle, right? So you can create the pressure in the inside. म्हणजे ह्या साइडला जो मटेरियल असेल, they can also participation in the that mixing, right? हे दोन वॅफल्स आहेत. ह्या साइडला कुठलाही कंटेनरमध्ये डेड स्पॉट राहिला नाही पाहिजे. डेड स्पॉट अवॉइड करण्यासाठी, राईट, यू कॅन यूज द बॅफल्स, बरोबर. आणि हे जे मटेरियल बॅफल्सनी काय होईल, हे मटेरियल परत ते आतमध्ये येईल आणि ह्या बॅफलनी परत हे आतमध्ये येईल and you can participation in the mixing mechanism, right? So these are small size, the mixing vessel is there, so which are in this laboratory method, but also have the different larger size of the tanks are there, maybe lakhs or maybe thousands of kg of the containers also there, but assembly is same, right? So it's attached with the motor, it's attached with the different starter and the paddles, then attached with the cooling jacket is also there. Is a double jacket is there, so can cool that container. If you increase the temperature, so that temperature should be reduced again, right? Because the temperature is also required for emulsion. Understand it? So that's and then after increasing temperature and after preparation of that emulsion, that emulsion should be cool at a particular temperature, right? Then you can passing in the cooling vent is there. The double cooling vent is there. So this is double jacketed, the vent is there, so can passing that the cool water, right, through this vent, right, so can cool the emulsion. Understand it? So this is the small size of the mixing vessel is there. So general construction of the mixing vessel is impeller. You can use impellers or the shaft. Mixing devices, the impeller is mixing devices mounted with the help of the shaft. So shaft is attached with that, right? Can drive into the motor, is the same thing as that. The tank is made of the stainless steel. The top of the tank may be open or closed, is open or closed, both are there. The size of the tank is depending on the nature of the installation method. कुठल्या मेथड यूज करायचं आहे किंवा किती मटेरियल आहे त्याप्रमाणे तुम्ही size of the tank will be depend. Tank of the bottom is round bottom, is particularly this tank is round bottom is required. राउंड बॉटम का पाहिजे, समजा की राउंड बॉटम नसेल तर काय होईल, राईट? तर हे जे मटेरियल आहे यामध्ये राउंड बॉटम नसेल तर हे मटेरियल यामध्ये जाऊन बसेल, राईट? आणि ह्यामध्ये जाऊन बसल्यानंतर हे परत पार्टिसिपेशन होणार नाही, राईट? त्यासाठी हे राउंड बॉटमच कंटेनरचं पाहिजे, जेणेकरून जे मटेरियल आहे ते डिपॉझिट होणार नाही साईडला किंवा कॉर्नरमध्ये जाणार नाही आणि सगळे पार्टिसिपेशन होईल, बरोबर? सो दिस इज carrier to outlets, the coil is required, jacket is required, so temperature measuring device is also required. So again we can use the thermometer into that. With the thermometer we can check that temperature or different temperature sensitizing cord is there. You can just immerse into that liquid and see the temperature of the inside liquid, right? So these are different components of the mixing vessel is there. So energy is required for and create the pressure. With the creating pressure to can reduce the larger global size to the smaller global size with the help of the impellers, air jet and the liquid jets, right? So these are the different things are there. So that part will be see afterwards, okay? So in next lecture we will see, okay? We'll stop here today. You can leave the meeting. Are you understand this, all this? Are you understand? समजलं सगळं? चला. हे पार्टिसिपेशन स्टुडंटचं पार्टिसिपेशन अजून कमी वाटतंय मला. कसं काय?
काय माहिती